So, our next presentation is entitled Shiny App as a Novel Assessment Tool for Pilots in Training, and is presented by Randy Boyce and Umair Durrani. So Randy is Director of Analytics at Presage Group Inc. He is an epidemiologist in training, currently working to understand human decision-making on Presage Group. He lives on an island near Kingston with his wife and 3 dogs. Umair is from the University of Windsor. He completed his PhD in civil engineer at the University of Windsor in 2022. He also worked as postdoctoral fellow at Transportation Systems Innovation Lab at the University of Windsor. During his 1 year as a postdoc, Umair created R packages and Shiny apps for the lab. I'm very excited to hear about this presentation because I think it's the first time I see an application of Shiny into planes and flights. So, guys, the floor is yours. Thank you very much for being here.
Thanks for the introduction. I'm going to start us off, and I'll talk a little bit about the motivation for the project, and then I'll pass off to my colleague Umair here for the more technical demonstration. As was said a minute ago, we're talking about our use of Shiny as a assessment tool for pilots in training. I'm going to advance the slide. So we both work for Presage Group. We're a Canadian scientific and technical consulting firm specializing in studying human behavior in the airline industry. We've worked for many airlines all across the globe, studying how pilots make their decisions in the moment. We have 2 additional colleagues who couldn't be with us here on the presentation, Brooke Linden and Amy Ecclestone, and they contributed to this project as well. Sorry, I got distracted here. So, traveling by plane is extremely safe, but when we do see accidents, the direct cause tends to be, in more cases than not, pilot error. Now, we don't want to pin all of that on the pilot. The way that pilots make decisions is informed by the system that they operate in. That's the culture, the procedures that they operate with, all of these external influences, right? And we can study those kind of systematic factors, learn how they influence how pilots are making decisions, and recommend interventions or changes to those procedures to help them make better decisions. And this project is a little outside of our normal comfort area, but we were asked to help develop a simultaneous real-time assessment tool that pilots could use as they're being trained on new types and updated for recurrency to optimize their learning, taking into account the mistakes that they are making or the difficulties that they're having, characteristics of their personality and how they're making decisions, to integrate all of that and in real time, in collaboration with their instructor, provide them with suggestions for improvement based on our models of how they're making decisions. These kinds of tweaks can be small, but when you are expanding those across many pilots, we think that this has the potential to improve flight safety for millions of air travelers every year. Here, I'm going to pass it off to my colleague.
Thank you, Randy. So for this app, this project, these were the required features. We wanted the app to be obviously online, fast, and reliable. And this was a full-fledged app experience that we wanted to create. So not only act as a dashboard for the students, pilots, but also we wanted to take data from students and then show that data for each student separately, and also we wanted to create user interfaces for students separately as well as for instructors. And we wanted the app to be accessible on desktop, iPad, and on cell phone. So based on those features, we had these development questions. What framework should we use? How do we store and retrieve the data? How do we aggregate data? Because we wanted the pilots to see how they were performing, not only for as they progress in their training, but also compared to the other pilots. And authentication was also very important because the data was private for each pilot. We didn't want any authentication problems. And aesthetics were also really important because we wanted to have the app to be professional looking, and with the older version of Shiny, we wanted to have an upgrade. So we chose to use Golem framework here, and instead of using Shiny Mobile, we used Shiny, because with Shiny you could also now use bslib for aesthetics, as we'll discuss in a moment. And Golem also, because it requires the package, an R package, to be created first. That package can then later be used for downstream analysis, because we create functions for the dashboard. We can use those functions for downstream analysis as well. And how to store and retrieve data? We already use Google Cloud, and so a natural option here was to use the Firestore database, which is a Google Cloud NoSQL database. And we created our own package called FRStore to interact with the Firestore database via httr using the REST API. And to aggregate data on schedule, we use GitHub Actions. For authentication, there are awesome packages already. I'll discuss that in a moment. But we use FRBS, as we'll discuss. And for aesthetics, we use bslib because it made it possible to show the app and use the app on different sizes of different screen sizes. So let's take a quick look at a demo app. So this app is not the original one. This is an example app. So imagine that you are a Shiny developer in Star Wars Academy, and there you have pilots, and some of those pilots are also Jedis. So we want to see we want those pilots to see how they're performing, and they also have an instructor who wants to see how they're performing. So let's sign in as Luke. So you can see the app login screen is customized. Uh, okay, let me refresh. Okay, it's not working, but I can show you the demo in other screenshots I have here. So let's build this example app, and we can, if we have time at the end, I'll try to log in again. So the first thing you need to do is to create a Firebase project. And you go to the console.google.com and then create a Firebase project. This would give us some credentials that you want to use in the app. If you go to the project settings, this is where you need to create a web app. And once you create it, it will give you the project ID, which is what's needed. So project ID is what you can copy and then paste here in the R environment. The next step is authentication. So Firebase provides multiple authentication options. Uh, Email and password is the most common one, but you can also use Google, GitHub, Microsoft, and so on. And there are existing packages like Firebase that let you use a built-in UI and a login. With that, it is pretty good. But we wanted to have more control over UI customization. And we also wanted to let the students sign in with an ID instead of email, but it's not possible with the Firebase package. So we use this new package, FRBS, which enables you to create account and sign in. And then with a little hack behind the scenes, you can let the students sign in with ID, but instead use an email behind the scenes. So FRBS also enables you to create custom screens for login. Here's an example from FRBS examples. And the login screen that I showed you before is controlled, is customized using FRBS and bslib. So because we wanted two different user interfaces for students and for instructors, we first check if the ID matches with a given student or instructor, and then based on that, we launch the corresponding UI. So here we see a student UI on the left and an instructor UI on the right. For the database operations, we chose Cloud Firestore. It's a NoSQL database. Unfortunately, there is no official client library for R. There is one for Python. So we were left with using REST API. So we created this package, FRStore, that uses httr behind the scenes to let you create, read, update, and delete student data. And these are the functions that we used, that we created to do the interaction with the Firebase, Firestore database. So here's an example where we are providing recommendations for students. This is the instructor view of the dashboard. And this is an example of reading the data from the NoSQL database. Here is a writing example where an instructor is generating a new questionnaire for the student. And this questionnaire is based on some event that happened during their training. So by the way, these buttons that you see here, these can be generated in the DT table, and I have provided the link at the bottom of the slide. And there's another read example. This is from the student's point of view. When they log in, they see this option to start the questionnaire that the instructor created for them. For aggregating data on schedule, the main requirement was that we wanted the student pilots to see how they were doing compared to an average pilot. And we wanted to, in this example, you can use Homeworld and Starships in the Star Wars data to look at performance by these two factors. So here in the screenshot, you see that there is an average. This is eCharts for R and the first view. And here we have a ggplot that shows the performance of a pilot in different aspects like memory and power management compared to an average pilot. So to create the averages, if we created the average on the fly, that would take longer time because as the number of students grow, the time it takes to take the average in our process would take very long. So instead, we chose to run the GitHub action of taking the average nightly. So this setting that you see for the schedule runs every night at midnight, and you need to specify the Firebase project ID to sign in. install the required packages that are used for calculating the averages, and then provide the R script that does all the average calculations. And for aesthetics, as I mentioned before, bslib was immensely useful to create multiple pages using navigation panels and navigation items. We have the if you see here on the top right, the navigation items that contain a button for providing feedback. We also use the layout columns setting with bslib to provide these value boxes and accordions that tell the student what demographics are used for creating the average, and what questionnaires they have completed or they need to complete. So in conclusion, we were able to create the app and met our required features where we could take data from students and show them their own data right away, and also help them see how they were doing compared to an average pilot. We were also able to create separate student and instructor user interfaces. And this app is still in development. It is working great on desktop and iPad screens. For cell phones, we're still working on it. But with bslib, it's making it possible to easily create questionnaires on smaller screens and let the students see their data on smaller screens as well. So I've linked to some resources here. Let me try, we have, I think, 1 minute. We try once more to log in to show you a quick demo if it works. Yeah, so this is that same interface, and this is where you can provide anonymous feedback. So the app is available here, and thank you for having us for this presentation.
So thank you very much. It has been very interesting, and we all could see that you have solved technical challenges in many parts of the application, backend authentication, performance, the UI. One question from Samuel Calderon was if libraries, FR Store, and FRBS are open source.
FRBS is open source. We did not create it. So I can later provide a link in the chat for FRBS. FR Store is not yet open source, but it may be in the future.
Okay, thank you. And yeah, maybe a second and last question would be if you have any plan to add further customization, because these apps that are that have a large number of users, and maybe they want more personalization. If you have some plan, like theming or some different UI, more personalized.
Yes, if there is a need for adding more customization like theming, we'll definitely do that. And it's very easy with bslib now. Yeah.
Okay, so Randy Umair, thanks again for this interesting presentation.